So thank you very much for coming. I'm going to talk about this randomized trial. I've spent 7 years, or actually 10 years, nearly 10 years doing this large randomized trial. And we just got the results just in the summer, and we published the first paper in November or something like that, October or November. And I'm just starting to try and understand the results. Sometimes, you know, I've noticed in previous trials that it takes me quite a while to understand the results. So I'd like your help to understand the results. Because I know there are lots of statisticians in the room, and there's some clinicians. So I'd like to hear your opinions. So please don't be shy. So this big randomized trial, the CRASH-3 trial, follows another trial we did of there's this drug. It was invented in Japan, and it's called Tranexiamic acid, and it reduces bleeding. You know it as Tranexiamic. And we did a big trial called CRASH-2, where we used this drug for people who've been stabbed or shot or in car crashes, and we just in car crashes, and we just, whoa, it's gone. Never mind. That slide shows a reduction in mortality. So this drug really worked, and there was a highly statistically significant reduction in mortality. And most of the reduction in mortality was due to a reduction in death from bleeding. So are you familiar with these kind of pictures? Yeah? The treatment effect in a randomized trial is the relative risk. And this is the relative risk scale on the bottom. This is a relative risk of 1. So if the treatment, and you know, there's no treatment effect, the relative risk is 1. If it's less than 1, it's a benefit. So we found a reduction in the risk of bleeding to death with tranexamic acid, and this very strong time to treatment interaction. So if you give the treatment early, it's much more effective, and if you give it late, it might be harmful. So this was the background to the trial. And so when people have been shot or stabbed, tranexamic acid stops people from bleeding to death. But this man has had a head injury. So his head has been hit by a car, and he's bleeding inside his brain. So this is his CT scan, and this is when he arrived in the hospital. This white stuff here is blood, but it gets bigger. 12 hours later, it's gone from this to this. So he's bleeding inside into his brain, and this bleeding inside into the brain can kill. So we wondered, if tranexamic acid can stop, you bleeding to death from shootings and stuff in the body, perhaps it can also stop you from bleeding into the brain. And bleeding into the brain, head injury is just a huge problem in the world. It's just enormous. There's something like, 2 or 3 million deaths every year. So it's an enormous problem, and there's probably about 60 million head injuries, or 60 million significant head injuries every year. So if we could find a treatment for this, it would be very good. Now, before we did this trial, before we did our trial, there were just 2 small trials. And they were this trial that we did and another trial that they did in Thailand. But they were very small exploratory trials, and you can see they've got very wide confidence intervals. But if you add up the results in a meta-analysis, it suggests quite a large treatment effect. And but we didn't really believe it. Meta-analyses of small trials with big treatment effects are not very reliable. Often you get big treatment effects and they disappear when you do a bigger trial. So we wanted to do a bigger trial. So this was the evidence before we did the CRASH 3 trial. And then this is the plan for the CRASH 3 trial. So we wanted to do a very big trial with hundreds and thousands of patients around the world.
So you showed the page, one page before you showed the RR. RR is what? RR is R squared?
It's relative risk.
Relative risk.
Yeah, sorry, it's a relative risk. So, but thank you for interrupting me. So please do that. I hope others will follow your example.